Okay, so 262, let's find our 262s and look at those first. We didn't have a chance to look at that last week because of the snow out. So 262, here's a breakdown of how we do that. On 262, where do you look first? What part of the problem?
Bottom.
Bottom. Look at all the bottoms. So for number one, we look at all the bottoms, and you pick a thing called the LCM. For number one, what are you going to pick for the LCM? Anybody on 261 looking at number one, what are you going to pick for an LCM? An X. That's all we see is an X. So what we then do is we multiply that everywhere. That multiplies the fraction, that multiplies the 4, that multiplies the other fraction, that multiplies the 3. But that LCM is going to multiply everybody. When it multiplies the fractions, what's its job? Why did we pick the LCM? Why are we multiplying? What valuable service will it do to algebra kind? Cancel out the bottoms. So when we multiply by this x, it's going to cancel out all the bottoms, and you're going to write down the tops. And if you didn't have a fraction, it's going to multiply that. So number one answer should be a 1 that had its bottom canceled, plus 4x, all on the top of a fraction. The bottom would have a 1 that got the bottom canceled out also, minus a 3x. Anybody need help on 1 with a 1 plus 4x on top, 1 minus 3x on the bottom? Let's look at 5, talk out 5. For 5, what would you pick for your LCM on 5?
X, Y.
X and Y. So this time we're going to get a little bit of canceling on the bottoms, and the extra bonus stuff that's left is going to multiply the tops. Anybody have a theory on 5 answer?
3y plus 4x and 4y minus 3x.
That's correct. 3y plus 4x on top, 4y minus 3x on the bottom. 7 will be the first one that you're able to factor and cancel. So if you didn't factor and cancel on 7, you're going to need to also do that on 8. 7's answer is going to be an x plus y on top of an x. 11, 12 look like they have some factoring and canceling. 10 looks like it has some factoring and canceling. 9 didn't factor cancel. 9 you could have factored, but it won't cancel. 13, I dropped you a hint right as we were running out of time. We re-recorded a bonus bit of knowledge. X to the negative 3 needs written a different way to make it look friendlier. What's x to the negative 3's exchange?
X over.
It's a fraction involved.
1 over x to the third.
1 on top, x to a positive 3 on the bottom. So when you copy down your problems on 13, 14, you need to do some exchanges like that to make those doable. 15, 16 was a thing I called factor mania. If you did 15 right, you'd get a y plus 3 on top, you'd get a y plus 5 on the bottom. 17, 18 are the hardest two. 19, 20 would have the same sort of rewriting idea that we talked about 13, 14, this kind of a thing. So let me just take a pause there, and if you need an answer, I'll tell you. If you need some help, I'll do it. Anybody have something?
So 17, I looked at the back, I got the wrong answer.
Okay.
I have no clue how to do it.
Well, let's do 17 in a minute, but let's do something else maybe first if other people want it to build a little momentum up before 17, but we can do 17. Anybody need any questions other than 17, 18 to build a little momentum before we try to take down 17, which is the 17 and 18 are the worst too.
19.
19. So 19, anybody have a theory on, instead of 3a to the negative 1, what am I going to write? Close.
3 over x.
3 over a. Plus the next piece, I'll write
3 over b.
3 over b
6 over b.
minus 6 over 80. For bottom,
4 over x. 4 over b.
Anybody on 19 have a question about how I rewrote a couple of those to be fractions based on an idea like that? So look at, always first, look at all of the
AB,
bottoms. We see A's, B's, we pick an LCM,
AB.
AB. The goal of this LCM is to do what again?
Multiply.
It's gonna multiply, but what's its goal? What's it gonna accomplish? It's gonna cancel. We're gonna cancel all of these bottoms. So when we move ahead a step, probably still a 3, a 6, probably a 4, an 8, probably all these signs still there. It's just a question of what's gonna happen with the variables. So here we get sort of a cancel, but we're left with a bonus B, this,
A.
A, this, nothing, because it's a total cancel. This, B, A, nothing. And that's like the main series of steps. Look at the bottoms, pick an LCM, and then multiply everybody. That's going to cancel all the bottoms, and it's going to change the tops maybe a little bit. Question about the main idea of that section? Then there's a sometimes finish. What's the sometimes finish? Take out a GCF if that's going to let you able to cancel. So on top, can we take anything out of this?
Yeah.
3. 3 can come out and leave you
B.
plus A
But minus
minus 2. On the bottom, take out a 4, which leaves you
B plus A.
the exact same thing, which means those parentheses
Cancel.
cancel, and our best final answer is 3 over 4.
Okay.
20 should go about the same.
Yeah.
20 doesn't get the good cancel though. 20 is going to go more like to this point and then dead end. You won't get,
Okay.
it will have GCFs, but it won't create a cancel the way that, that 19 did. So you can't just eyeball these and be like, looks like it might be 3/4. No, 20 looks like it might be 5/6. It isn't. It's a thing that doesn't cancel. It's a really big answer on 20. Anybody else something before we take on 17?
9.
9? 9. So 9, I got an A minus 3A over B. I've got a B minus a B over A. So who's my LCM? AB. Here we get a sort of cancel. There's some leftovers here, there's some leftovers there. That stuff all has to multiply. Off of this imperfect cancel, what's that gonna make?
3A squared.
3A squared is true. Here we get another imperfect cancel. We get some leftovers here. We got some leftover tops there. That's gonna make us get
B squared.
B squared. Anybody trouble with that? And here there's no canceling, so you just straight out multiply. There's not even a fraction there. So just straight out multiply everybody. A squared B. Here we straight out multiply everybody again.
AB squared.
AB squared. That's always a process. Pick the LCM, cancel all the bottoms, multiply everybody that's left standing, get an answer. Maybe we're done, maybe we're not. What do we try to do to this? And maybe it works, maybe it doesn't. Try to factor. On top, we could take out A squared to get B minus 3. On the bottom, we could take out
B squared.
B squared, which leaves,
A minus 1.
but it doesn't matter if we do or don't do that step this time, because nothing's able to cancel. So if this is your answer, I'm good. If this is your answer, I'm good. You kind of just pick an answer, either answer. The book went with the factored answer, but I'd be fine with the unfactored answer.
I think that's what it was, is that the book had the factored answer in the back, and I didn't realize, like, I had the first thing, I
Okay.
didn't realize they were the same. I was
Yeah.
like, what did I do wrong?
This would be acceptable, it doesn't really matter. it's a good idea to always think about factoring. So I think when they were thinking about factoring, they wrote it down. And once they had written down that factored answer so that they could see if it was going to cancel, then they were like, I'll just put that because I already factored it. This looks less scary. I mean, if I had to argue for which answer is better, I'd probably argue for this because it's less scary looking. But if you said which answer is right, I'd say they're both equally right. Anybody, something about 9? Anything going on with any of that? Okay, let's take on 17, and then while we're taking on 17, why don't you hunt down your 266 page, whatever you have there. So 17, I've got an x, I've got a 1 minus x. This is like it's in parentheses whether I wrote that or not. This has a 1 plus x, this has an x. This is like it's in parentheses whether I write them or not. This 1 minus x is on top of an x. This x is on top of a 1 plus x. So when we go to pick our LCM, who's got to go?
1 plus x.
1 plus x is in there.
1 minus x.
1 minus x is in there.
X.
X is in there. All three of those things are in there. Question about picking LCM there? So this would cancel the 1 minus x. So in our mind, this is gone. There's a bonus x that wants to multiply this. So call that x squared with a friend.
1 plus x.
1 plus x. I'm going to leave that to just stew for a minute. 1 plus x.
Squared.
Here, we're going to get a cancel of the x's. And who are 1 plus x's, friend, or friend's going to be?
1 plus x, 1 minus x.
1 plus x and 1 minus x. I could put them both. Maybe I even should put them both. I don't really want to put them both. What am I going to have to do with these an hour later anyway? I'm going to have to multiply them out. I'm going to have to FOIL these out. So let me just FOIL them while I'm just seeing them before they're with their friend. If we FOIL this,
Negative x.
we'd get a negative x. We get 4 things out of them.
You get a 1.
We get a 1,
1x.
a negative 1x, and a positive 1x, which would
Cancel.
eliminate,
X squared.
and a minus x squared. So who's left standing?
Minus
So
x squared.
So 1 minus x squared.
1 minus x squared would all be left standing. Let's pause there and make sure we didn't lose anybody. So when we attack this, the minus thing canceled. These two survive. This x multiplied that x, that's the x squared. And then I brought the friend. Here we canceled x's, so both of these were left standing. This is going to have to FOIL with both of them. I just FOILed them in advance before I even introduced them to his friend. Does that make sense so far?
Okay, yeah, I still have that.
Anybody not okay with where we got so far? Okay, so let's go here. This x would cancel this x. And this 1 minus x would encounter how many friends?
2.
2. Which 2?
Those 2.
Wow.
Those 2. Which we just did a second ago, and they haven't changed. They're still going to make
1 minus x squared.
1 minus x squared. When this cancels this, those are going to be gone. So this x is going to get these in its family. So the x's would make
X
X
squared.
x squared with what other friend?
1 minus x.
1 minus x. Woo! That's what makes that go in this section. That's the process we always do. Pick the LCM. LCM cancels the bottoms. All the leftover stuff, the tops that are left over and the leftover from the canceling LCM, that all has to like go together. This one's just meaner because there's more like work to do than usual, but we can do it. Question about process so far? Just focus on this little top corner before the plus. That's comfortable. What's that called? What are we doing there? Distribute. So if we distribute,
X squared plus X.
x squared plus x cubed. Plus, multiply these, just worry about this corner, this is called foiling. We're gonna get how many items? 4. So 1 times 1.
1.
1 times a negative x squared.
Negative X squared.
X times 1.
1.
X. X times a negative x squared. Negative x cubed. Question about the top before we move to the bottom. Then what's this? What's that called? Foiling. It's slightly different from the one we did, so let's just redo it. 4 items again though.
1.
There is a 1.
Negative Y squared.
Negative x squared is there. There is a negative x in there. There is a positive x cubed in there. And then what's going to happen to this? This is called distributing. Has a positive
X squared.
x squared minus
X cubed.
x cubed. Question about all that? Distribute, foil, fun times. You okay to that? So then we try to clean up. So let's just look at the top, and I'm going to break out my eraser. No, I'm not going to break out the eraser in case people are still copying. I'll just gently scribble out. What could I have erased if I wanted to? X squared. So there's a positive x squared, there's a negative x squared, those are goners. X cubed, so there's a negative x cubed, there's a positive x cubed,
1.
those are goners.
1.
The top grand total left with
1 plus X.
1 plus x, or x plus 1, whatever order you do, you do. Bottoms, anything on the bottoms can go? X squared, so there's a negative x squared, there's a positive x squared, vanish. X cubed, positive x cubed vanishes with a negative x cubed. So left standing, 1 minus x. And then let's see if that's what they think it is. That is what it is. We agree. 18, when you go to try 18, everybody try 18. It's a similarly difficult problem, but it doesn't drop as well at the end. You're going to get more to a point that looks of this size, and then it's just there. It's not going to go anywhere. You're not going to get as much like combining away. You're just going to get a big monstrosity and have to give up because nothing's going to vanish. Yeah, I shouldn't say nothing will vanish, but not nearly as much stuff is going to like pop away. Anything 261 spills into 262. If you can get that, you have dominated that lesson. If you can get 18, you are truly dominant on that lesson. I'm not asking you to work it until you get it, but what I am asking everybody to do is try 18. It's of a similar size to 17.
Are you ready to give up?
Question about 261. And let's move down a line. I'd be strongly expecting to get those tomorrow because I doubt if a ton of people tried 17, 18 yet. Steal 17 off the board. There it is. Like, take it. That's yours for free. But you've got to at least try 18 and steal 17.
I'll just...
266.
No, it's in a
If you didn't watch the video, I'd rather you not really ask me questions because that's why the video was there. If you did watch the video and you got into some log jams, I'm happy to help you out. But you need to do your part first before you ask me to like do everything for you. So 6.5, watch the video, see if that explains it. If not, let's do some stuff up. So 266, anybody have this started and ran into any sort of troubles? Yeah? 19. Let's go first. Anybody have anything on 1 to 12? Were there any 1 to 12 issues? Let me give you an answer or two on the 1 to 12 just real quick. There shouldn't have been any fraction answers. Everything was able to completely divide. Let me just give you the last answer, because that looks like the scariest one. So 12, we skipped 3. 11, if you got a negative 2pq plus a 3p minus a 4q, if you got that one, you're probably good. Anybody 1 to 11s? Okay, so let's hit up 19 then. Does anybody want a picture of this before I clear my space to be able to do 19? Yeah, we'll do a picture taking timeout from people.
I got you.
So this is number 17.
Very good.
Okay. Anybody need a picture taking timeout before we clear room? So if you didn't watch the video, here's just an accidental reteach. When I do 19, just kind of listen in. So 19, we're going to go y minus 2 out, y cubed minus 4y squared plus 3y minus 6 in. Some of the questions skipped some of the powers in descending order. What do you do if they skip a power in descending order?
Leave a space.
Let's leave a space. So if this didn't have any y squareds in the problem, I'd still have a vertical space where all my y squareds could fit. So if they don't go 3, 2, 1 number in order, leave a space where they skip somebody. When you go to divide, who do you look at? Where do we look first when we go to divide?
First number.
The very first number of this, called the divisor,
And first number.
and the very first number of the dividend. That's all that matters. The video took you on like a 7th grade or 4th grade life, kind of like flashback. If I gave you this, you don't try to think about your 21 times tables. You just worry about 2 dividing into 14. 2 goes into 14 7 times. So you probably go with 7. If we go to divide these, what is that going to make if we just divide the leaders?
3. Or 4. Okay. Cube.
Y cubed,
What does this have?
1.
A 1 invisible. Divide this and this.
And then we square.
Squared. Because when we divide, what do we do with powers? We subtract. If you have trouble doing that in your mind, what the video is coaxing you to do is take those for a walk. Take y cubed for a walk. Take the y to the first on a walk. If we cancel these, top wins by
2.
top wins by 2. That's why that's a y squared. Question about the y squared so far? Good on that? Then let's take a 4th grade flashback. Once we settle in on the 7 in our 4th grade life, then what does 7 do?
Multiplies.
Multiplies everybody. So we get 1, 4, 7. So this y squared multiplies everybody. Y squared times this makes y cubed. Y squared times this is negative 2y squared. Then we draw a line that symbolizes that we're about to subtract. You probably got real excited about these matching because when you subtract, they're just gone. 9 minus 7, 2, and then this
There you go.
drops. So you get real excited here. These match, so they just
Going.
disappear. We're subtracting a negative, that's where you have to be careful. Subtracting negatives makes you flip the signs. Subtracting negatives makes adding. So negative 4 is adding 2.
Negative 2 plus 2.
It is negative 2y squared. And then just like we dropped the 7, we drop that stuff. And that's what I would call round 1. You okay with round 1? If this were our problem, we just kind of like then do it again. You know, 2 into 2 goes once, and we just like go some more. We're going to focus that same way. We're still looking at this, But now we're looking at the first one of these. If this divides by this, what are we gonna get if we divide the liters?
Negative 2y.
-2y. Then -2y has to multiply everybody. So -2y times the first one is -2y squared. We should always create a match. If you don't create a match at the beginning, you messed it up. What's in this position?
Also,
Positive 4y. Careful of signs, negative times negative makes me positive. Then I draw my line, because in my mind, it's time for me to subtract. These two should always just vanish. Positive 3 subtracts positive 4. 3 minus 4 is -1. And then this 6 thing, just drop it like it is. The top is never going to switch a sign. We're switching the signs from the lower level because we're subtracting. And then we go one more time. -y dividing by positive y is -1. -1 has to multiply everybody. So -y for perfect match, positive 2. When we subtract, vanishing act there, -6 subtracting positive 2, -8. And then I don't remember what the book does, so I'm going to take a peek. They mix it up. On some of the questions, they wrote remainder, -8. So if you write remainder, -8, fine. That's correct according to them, because I see them doing that on some of them. What else can you do with remainders from your division life? They can be written as a fraction. So if you don't want to do the remainder thing, you could go minus, because it was -8 on top of
7 over -7.
No, y over.
Y minus
the
-7.
divisor, the one
Whoa.
equals to.
Get a little bit like kicked over there.
Either answer, either way it's written, I don't care, whatever you want to do.
No,
That was your question, does that process make sense? Okay. My opinion, there's not really easy or hard ones of these. They just like are what they are. They're all kind of the same. Every once in a while you'll bump into somebody with no remainder. That doesn't mean anything really, it happens. Sometimes you only have to go, this time we went 3 rotations, maybe there's some that you only had to go 2 rotations, I believe. But most of these answers have either 2 or 3 rotations of division cycle. Anybody 266 that tried something that has other stuff that had you stuck? 29. What did you get for your first thing here? Did you get that far? Okay. Try it. Try and see what you get. It should be like the same style as 19. Anybody else something that you have started? I have a question about 266 kind of stuff. Quick just thing to tell you. Here's, if you want to know how many rotations you're going to go before you start, look at how much different the powers are. These powers are different by 2 powers. That means you're going to get 3 numbers before your remainder. If I set you up with a question where this is y to the 4th and this is y to the 10th, how many numbers would you end up getting up here?
7.
7. The difference in powers is 6, and then it's always 1 more. You get 7 numbers worth, and there's nothing that's going to be of that size. But if somebody lost their mind, and this had y to the 3rd, and this had y to the 100th,
Oh boy.
how many cycles would you have to go? 98 cycles, because the difference in power is 97, and then 1 more than that. You'd go 98 cycles before it stops, and that'd be insanity. But if you want to know before you start how many cycles there are, look for the difference in powers, and then it's 1 more than that. So when they started you off with y's and y squares, the difference there is only 1, so you're only going to have to go 2. Later in there, they gave you some problems that were 2 that forced you to go 3. But I don't think they did anything. The very end, They had some where what was the biggest difference? Biggest difference in powers on that page? 3, which meant you had to go 4. 4 was the longest. 266s might be done. If 266s are done, send those down. If you did try 18 on that other page, you could send that down, but I'm somewhat doubtful. You got tomorrow, you got the next day, grade period ends. The tomorrow assignment has already been in your hands for more than a week. What's the tomorrow assignment? Worksheet. There's a worksheet from 6.1 to 6.5. That's tomorrow's game. Wednesday, a quiz that's like that. That's where we are. Welcome back to life. This should be pretty much a regular week of algebra. There's no weather still lurking around this year.